Hello students, today we will be studying about the chemical properties of non-metals. Now we have already studied the physical properties of non-metals and we know that what are the physical appearance, how they act, whether they are good conductor or bad conductor, that we have studied. Do you remember? We should have a quick revision for that. I think so. Physical properties of non-metals, most of you might be knowing thoroughly because they are just reverse of metals. Only a few exceptions are there. In that cases, you have to remember them. Okay. Like if I go for conductivity, that is a good conductor of heat and electricity. Then here an exception is that is graphite. Okay, graphite conduct electricity, although being a non-metal, that is an allotrope of carbon, then also it conducts electricity. Okay, uh, so in this manner only we can talk about its states. The states of the non-metal is they exist in all three states: solid, liquid, and gases. Now the densities of non-metals are generally low. They are having low density. Exception is iodine and diamond, which are having density comparable to the metal such as aluminium. Some you can see that some non-metals they are such that you can see that they are having high melting point. Actually, the property of non-metal is that they should have low melting and boiling point. But again, graphite, which is an allotrope of carbon, has high melting point. Okay. And another exceptions you have to see, then even silicon and boron, they are also having high melting and boiling points. Okay, so now we'll be starting with the chemical properties of non-metals. Now we have studied the chemical properties of metals, and we know that how metals react towards different conditions, like in presence of oxygen, in presence of water, what is their reaction. Now we'll see similar for the cases of non-metals. First we'll see reaction of non-metals with oxygen. Non-metals react with oxygen to form acidic or neutral oxides. Now we know what do we mean by acidic oxides or neutral oxides. The acidic oxides are those oxides which when dissolved in water they will turn, and if you insert a blue litmus it will get turned red. Okay, this means that a non-metal forms such oxides which are acidic in nature because they are turning the blue litmus red. Okay, so this is the basic. We can say that the oxide of non-metal acts. Some oxides of non-metal even act as being neutral, means they do not turn blue litmus red nor they do turn red litmus blue. They are neither acidic nor basic. They are neutral in nature. Okay. So first we'll see some examples of the acidic oxides formed, and then we'll see about the neutral oxide. Acidic, that is, these turn blue litmus. Example we can see first is the case of carbon. Carbon, when reacts with oxygen, and when the oxygen is present in large amount, then it will form carbon dioxide. Okay, when here oxygen is present in excess. Oxygen is a gas. I'm making the symbol for gas, and carbon is solid. Okay, so carbon reacts with oxygen of air to form carbon dioxide gas. This carbon dioxide gas, when it is dissolved in water, it will form carbonic acid, and due to this acid form, this oxide has acidic nature. So when this carbon dioxide gas is dissolved in water, then it will form an acid, that is H2CO3. The name for this acid is carbonic acid. Carbonic acid is having two replaceable hydrogen, and so its basicity will be 2. Okay, basicity is the number of replaceable hydrogens in an acid. Okay. So here we can see, as there is a formation of an acid, therefore the blue litmus turns red when we dip a blue litmus paper in it. Okay. So this shows the acidic character of CO2. Next is an example of sulfur. Sulfur solid, when reacts with oxygen of air, which is in excess, then it will form an oxide, that is SO2. Okay, this SO2 again, when it dissolves in water, it will form an acid, that is sulfurous acid, H2SO3. Okay, this acid is called sulfurous acid. Next is when phosphorus is burnt in air. It reacts with oxygen of air and forms phosphorus pentaoxide. This phosphorus pentaoxide, it dissolves in water and forms phosphoric acid. Phosphorus P4 is written because phosphorus exists as a tetraatomic atom. It is for having 4 atoms in one molecule of phosphorus, and therefore it is called as tetraatomic. Okay, because 4 atoms are combining to form one molecule of phosphorus, and it is stable in that case. It exists in that way. This phosphorus, when combines with oxygen, it forms P2O5, that is phosphorus pentaoxide. The name is phosphorus pentaoxide. Okay, this phosphorus pentaoxide, it dissolves in water and it will form an acid, that is phosphoric acid. P2O5 plus H2O liquid, then it will form phosphoric acid, that is H3PO4. Okay. As these oxides, when dissolved in water, they are forming acids, and acid has the property of turning blue litmus red. So we can say that these oxides itself are acidic in nature. So these were some examples of how the oxides, when dissolved in water, they are giving acids. We can also say that these oxides are the anhydrides of these acids. Okay. The new term for you here is the word anhydride. Over here we can say all the above oxides are the anhydrides of their respective acids. Now the word anhydride. This word, what does it mean? Anhydride means when water is removed from any particular compound, then its anhydride is formed. Okay, when I remove water molecule from an acid, then it will form an anhydride. From any such compound, when water can be removed, then the formation of another compound takes place, and that compound is said to be the anhydride. Okay, because water is removed from it. Okay. Now just we'll see how does this happen. For example, I said in the case of carbonic acid. Now the carbonic acid, that is carbonic acid, here we can say it is an oxy acid. Now oxy acid means when oxygen is having the hydrogen which is replaceable. This hydrogen and this hydrogen. These both hydrogens are replaceable, and that is why I said that it is dibasic acid. Its basicity is 2 and it is an oxy acid because oxygen is attached with the hydrogen which is removed. Okay. The acid mean all of we know that according to Arrhenius theory, acid is hydrogen ion donor, that is H plus donor. Okay. So here it is an oxy acid because oxygen is attached with the hydrogen which can be donated or which can be replaced. Now when I am talking about the oxides, here we can see when water molecule will be removed, then in this case there will be formation of the acid, that is there will be formation of an oxide, that is CO2. Okay. So when I will remove water, H2O, OH and H from here will be replaced and there will be formation of CO2. Okay. This is the acidic. So when water is removed from the acid, it forms an oxide. Then that oxide is said to be the anhydride of the acid. So this was about the acidic oxides of nonmetals. Now we'll see nonmetals also have the tendency of forming neutral oxides. They do not form basic oxides, but they form neutral oxides. These oxides do not turn red litmus blue nor turn blue litmus. Okay. So these oxides are neutral because they do not have the tendency of turning red litmus blue nor blue litmus red. For example, in this case, we can see when carbon is burnt in oxygen, but the oxygen is insufficient, then it forms carbon monoxide. This carbon monoxide, it is neutral in nature. It does not form acid when dissolved in water, and that is why we can say it is neutral. Okay. Similar examples are oxides of some oxides of nitrogen, such as N2O, NO. These both are also neutral in nature. Okay. N2O is nitrous oxide. It is also called laughing gas. NO is nitric oxide. These oxides are neutral in. Another example is water itself. Water is oxide of hydrogen and it is also neutral. Okay. So these are some examples for neutral oxides. We can say that they do not turn red litmus blue nor do they turn blue litmus red. Okay. They are having the property of being neutral. These were some examples of the oxides formed by non-metals. Now we'll see the reaction of non-metals with water. Do water react with non-metal directly? Yes. Just see, non-metals are around us, such as nitrogen and oxygen itself. It is present in air. They do react with water directly? No, they do not react with water. We see when rain falls, water falls and it just comes down. The oxygen in air and nitrogen in air, they are not having any reaction with the water. This is a very simple example, and in our daily life we can say it is our visual example how we can say that non-metals do not react with water. Okay. Now the question arises, why do non-metals do not react with water? So now the question arises, why non-metals do not react with water or steam to give hydrogen gas? This is because water here should have. This is because nonmetals cannot give electrons to reduce the hydrogen ions of water and form hydrogen gas. Nonmetals have the tendency to accept electrons. It does not, they do not donate electrons. Now water forms H plus and OH minus ions. Okay. Now for hydrogen gas to be formed, this H plus ion, hydrogen ion should accept an electron. Okay. And then only it can form H2 gas. But non-metals, they do not provide this electron. And that is why there will be no electron to react with the hydrogen ion and form H2 gas. Okay. That is why we can say that there is no reaction of nonmetals with water. Next is reaction of nonmetals with acids. Here we are talking about the reaction of nonmetals with dilute acids. Nonmetals do not react with dilute acids and they do not liberate hydrogen gas. So again here we can say nonmetals do not react with dilute acids and so do not form hydrogen. The reason again here is the same. Dilute acid, suppose HCl, it will dissociate into H plus ion and Cl minus ion. These H plus and Cl minus after breaking for formation of hydrogen gas, here H plus requires electron and the required electron is not produced, therefore there is no formation of H2 gas. Okay, the required electron cannot be produced as nonmetals do not lose electron. Hence we can say that nonmetals do not react with dilute acid.